Hello all, this is Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. We are in the chapter of differentiability and already in our previous video we have discussed about the concept of differentiability along with few questions. Okay, in this second video of the chapter of differentiability, let us solve problems on differentiability, main top model problems for JEE mains and advanced, particularly okay now important models. I'll try to discuss all possible models on problems on differentiability using LHD and RHD. Okay, now using left hand differentiability and right hand differentiability, let us solve as many models as possible. And remember, while solving these questions, first we will check the continuity of the function at the given point. After that, we will check the differentiability at the given point. Keep this in mind. So out of the different problems that I'm going to discuss, here is one particular problem, so which I have written on the board. Okay, now so let us start solving the problems on differentiability using LHD and RHD. In case if you are new to the channel, don't forget to subscribe. I'll upload all possible concepts and problems from differentiability and upcoming chapters also in calculus. And don't forget to check the playlist. I have uploaded many chapters like limits, quadratic equations, theory of equations, inverse trigonometry and even other chapters. Do check the playlist when possible. Okay, now let us start solving the problems. Here is our first question. They told us to discuss the differentiability of this particular function at x is equal to 0. So where f of x is equal to sin x square by x if input is not equal to 0 and f of x is equal to 0 if input is equal to 0. Dear students, remember they told us to discuss the differentiability at x is equal to 0. First of all, we will check the continuity at x is equal to 0. And if the function is continuous at x is equal to 0, we will go on with differentiability. If the function is not continuous at x is equal to 0, obviously it is not differentiable at x is equal to 0. Okay, now, so keep this in mind. Unless you are sure that the function is continuous, you have to check continuity at x is equal to 0. In case if you are guaranteed that the function is continuous at x is equal to 0, directly you can go for differentiability. Okay, now slowly we will get that habit of doing it directly if we already know that it is continuous. Okay, for now in these models that we are going to discuss today, first we will check the continuity at the given point and after that we will check for differentiability. Okay, now so let us see. I'm going to check the continuity at x is equal to 0 because we generally get confused while checking continuity and differentiability. Okay, now by practice it will become clear. Okay, first let me check whether the left hand limit at x is equal to 0 is equal to right hand limit is equal to value of the function or not. Okay, so in this particular case you don't have to check LHL and RHL separately, is it? Directly I can find the limiting value of the function. Okay, so let me find limiting value of the function. Limit x approaches 0 f of x. Limit x approaches 0 f of x. So limit x is only approaching 0, it is not equal to 0. So x is not equal to 0 now, only approaching 0. So instead of f of x I can write sin x square divided by x. In case if you have practiced the problems in limits, you know what to do next. We will multiply the denominator and numerator with x. So what do we get next? Limit x approaches 0, x into sin x square divided by into x. So this becomes x square. When x is approaching 0, even x square is also approaching 0. So the limiting value of this particular function is 1. We have learned this in limits. So 1 into, here you can substitute x as 0. So 0 into 1 is 0. We got the limiting value of the function as 0. And what is the value of the function? F of 0. When input is 0, the output is also 0. So dear students, the limiting value of the function is equal to value of the function. Therefore, we can say that the function f of x is continuous at x is equal to 0. Therefore, the function f of x is continuous at x is equal to 0. Since it is continuous, let us go and check the differentiability. Remember, if it is not continuous, obviously it is not differentiable. Anyhow, in this case, the function is continuous. So let us check the differentiability. So I am going to check the differentiability of the function f of x at x is equal to 0. So already it is continuous. Now let us check the differentiability. First let me find the left hand differentiability, LHD. So LHD is given by f dash of 0 minus. And already we have learned that f dash of 0 minus is limit h approaches 0, f of 0 minus h minus f of 0 divided by minus h. In case if it is new for you, do check the previous video of differentiability, the introduction of differentiability. You will get more clarity about it. Find limit h approaches 0, f of minus h. So f of minus h, observe that h is not exactly 0. Okay, na? So therefore minus h is also not exactly 0. So minus h is not 0, I will use this function. So f of minus h means sine of minus h whole square divided by minus h minus f of 0. When input is 0, output is 0 only. Na? F of 0 is 0 whole divided by minus h. So what do we get here, students? Limit h approaches 0, sine of minus h whole square is h square divided by minus h divided by minus, you will get what? You will get sine h square divided by minus h, and when division becomes multiplication, minus h by 1 will become 1 by minus h. So what do we get in the denominator? Minus h into minus h, we will get h square. And from the concept of limits, we know that when h is approaching 0, h square is also approaching 0. So sin h square by h square is taking the value of 1. Okay, so the left hand differentiability LHD value, dear students, we have got LHD value as 1. Similarly, let us find what is RHD. Okay, now the right hand differentiability. Okay, now so in the same solution, I'm giving you RHD also. F dash of 0 plus, that is RHD. It is equal to limit h approaches 0, f of 0 plus h minus f of 0 divided by plus h. So that is RHD formula. So limit h approaches 0. So f of h means sin h square divided by h. So sin h square divided by h minus f of 0 is 0 whole divided by h. Okay, now so here what do we get? Here also we'll get the same thing. We'll get sin h square divided by h square. And from limits concept we know that the value of this is also 1. So RHD is also 1, dear students. So LHD is equal to RHD, both are finite values, both are equal to 1. So from this we can conclude that the function is differentiable at x is equal to 0. Therefore f of x is differentiable at x is equal to 0. Directly I did not check differentiability. First I checked whether the function is continuous or not, and then using it I have checked the differentiability also. Okay, so to understand it better, let us take another example. Let us solve another question. Here is our second question. Discuss the differentiability of this particular function f of x at x is equal to e. At the point x is equal to e, we are supposed to check the differentiability of this function. Okay, now so before checking differentiability, we are supposed to check continuity first. Let me check whether the function is continuous at x is equal to e or not. Okay, now so I'm going to check continuity of f of x at x is equal to e. See, in the previous problem, while finding the limits, I did not use LHL and RHL. But in this particular problem, I have to use left hand limit and right hand limit. Why means, observe, you are finding the limit at x is equal to e. Correct or not? You are finding the limit at x is equal to e, and look at this particular power. The denominator is becoming 0 at x is equal to e. Correct or not? The numerator is a finite value and the denominator is becoming 0. So whenever these kind of things happen, we will take LHL and also RHL. I have explained this detailedly in the chapter of limits, particularly in the concept of limits at infinity. I have told when to use LHL and RHL and when can I find the limit directly. I have discussed all this. See, the power is a rational function and the denominator is becoming 0 at x is equal to e. For this reason, I am using LHL and also RHL. First, let me find LHL at x is equal to 0. So, limit x approaches 0 minus f of x. Students generally get confused while finding continuity and also differentiability. They will particularly get confused while using this formula, okay? But when you practice, all these things will be easier, okay? It's very simple. Now limit x approaches 0 minus f of x. What is f of x? I'm sorry, it is not 0 minus, it is e minus. You are checking continuity at x is equal to e, right? Limit x approaches e minus f of x. If x is approaching e from the left side, x is not equal to e. Since x is not equal to e, I can use this function. So f of x becomes this. Limit x approaches e minus, what is f of x here? X minus e into 3 power minus 3 power 1 by e minus x. And the solution becomes easier if I convert x in terms of h. What is it? X is equal to e minus h, where h is positive and h is approaching 0. If you are following my previous videos of limits, all these things will be clear. Just like that, you will get the answers. So what is it? Next one, limit h approaches 0. Instead of x, I am going to substitute e minus h. Okay, now so e minus h minus e. Instead of x, I have written e minus h into 3 power minus 3 power 1 divided by e minus of, what is x, dear students? X is e minus h, na? Substitute e minus h. Okay, now plus e and minus e will get cancelled. Limit h approaches 0 minus h into 3 power minus 3 power. What do we get is 1 by h. We get 1 by h. E and minus e gets cancelled. Minus into minus h is plus h. Please observe one thing here. H is approaching 0. Then 1 by h is also approaching 0. Sorry, h is approaching 0. 1 by h is approaching infinity. So what are we getting then? Then what about this number? 1 by h is approaching infinity, na? What about minus 3 power 1 by h? So let me substitute that here. So it is equal to limit h approaches 0 minus h into 3 power minus 3 power 1 by h is taking infinity. And I am writing it directly. 3 power infinity is approaching infinity only, right? 3 power infinity is approaching infinity only. I am writing it directly. And please observe 3 power minus infinity. Improper fraction power minus infinity. What is 3 power minus infinity? It is 1 by 3 power infinity. That means 1 by infinity. And 1 by infinity is approaching 0. So what we get is, now if I substitute h as 0, I'll get minus 0 into 3 power minus infinity is 0. Because 3 power minus infinity is 1 by 3 power infinity, which is 1 by infinity, which is 0. It is approaching 0. Okay, now so 3 power minus infinity is approaching 0, and here is also 0. 0 into 0 is 0. So LHL value is 0. Left hand limit value is 0. Okay, now I got LHL as 0. Now let me find RHL also. Please observe one thing. LHL is 0. Value of the function is also 0. Let me find RHL in the same solution. I'll explain how to find RHL. So RHL is equal to x approaches e plus f of x. So x approaches e plus means x is equal to e plus h, where h is approaching 0. So in the next step, what will you get? Instead of x, I'll write e plus h. E plus h. Okay, now and here also e plus h will come. Okay, next plus e and minus e will get cancelled automatically. And next 3 power minus 3 power, what will you get? E and minus e will get cancelled, and I will get 1 divided by minus h. I will get 1 divided by minus h. Dear students, when h is approaching 0, and 1 second, here we have plus h into 3 power minus 3 power 1 divided by minus h. Okay, now when h is approaching 0, 1 by h is approaching infinity, and minus 1 by h is approaching minus infinity, right? Minus 1 by h is approaching minus infinity. So this particular value is there now. This becomes minus infinity. And what comes next? You will get limit h approaches 0, h into 3 power minus 3 power minus infinity. Dear students, 3 power minus infinity, as we have discussed already, 3 power minus infinity is 0. So what do we get then? 3 power minus infinity is 0 with minus sign. So minus 0 or plus 0, both are same only, na? So I'll get plus h into 3 power minus 0. 3 power minus 0 is nothing but 3 power 0. And 3 power 0 value is 1. Okay, na? and this is h. H is approaching 0. So 0 into 1 will be 0. Even RHL also is equal to 0. So what is the conclusion? The left hand limit is 0, the right hand limit is 0, and even the value of the function is also 0. Since all three are equal, we say that the function is continuous at x is equal to e. So left hand limit is 0, right hand limit is 0, the value of the function f of e is also 0. So all are equal now. So that we can say that f of x is continuous. Therefore, f of x is continuous at x is equal to e. Since it is continuous, now let me check whether it is differentiable or not at x is equal to e. In case if any of these are not equal, we will say that it is not continuous. If it is not continuous, it is not differentiable automatically. But since it is continuous in this case, let me check whether it is differentiable or not at x is equal to e. Okay. So we are going to check whether the function is differentiable or not at x is equal to e. First, let me find LHD, left hand differentiability. It is equal to f dash of, at what input? At x is equal to e. So f dash of e minus. And what is the formula to find f dash of e minus? Limit h approaches 0, f of e minus h minus f of this number e divided by minus h. Generally, we will do one mistake. What does it mean? By finding LHD, we will forget writing minus h here. We will write plus h and we will get wrong answer. Please be careful there. It is minus h for LHD. Okay now, and f of e minus h. Dear students, e minus h is not equal to e now. Since our input e minus h is not equal to e, I will use this function to find f of e minus h. I will use this function. So it is equal to limit, wait, I'll write here, limit h approaches 0, f of e minus h using this function. What is it? Instead of x, I'll write e minus h. So e minus h, x means e minus h, minus e into 3 power minus 3 power 1 divided by e minus of e minus h. So that is f of e minus h. I have written this. Minus, what is f of e? When input is e, f of e is 0. So divided by minus h. Next steps are easy. Plus e and minus e gets cancelled. Minus h in the numerator and minus h in the denominator also gets cancelled. Just while finding the continuity, I told you what is the value of this. Can you pause the video and try to find the value of this? So obviously 3 power minus 3 power 1 divided by, you will get h here, where h approaches 0. So 1 by h, when h approaches 0, 1 by h approaches infinity. So you will get 3 power minus 3 power infinity. So that means 3 power minus 3 power infinity is approaching infinity, and 3 power minus infinity is equal to 0. So I hope you got the same value. Dear students, left LHD is equal to 0. Similarly, what is RHD? In the same solution, I'll just make small changes to tell you what is RHD. But remember, I got LHD as 0. Now let us see what is RHD, right hand differentiability. F dash of e plus. And in the formula, limit h approaches 0, f of e plus h minus f of e divided by plus h. Okay now, so here what happens? Let me erase this and we will explain. So I'm going to use this function again. E plus h, input e plus h is not equal to e. Input is not equal to e. I can use this function now. So instead of x, I'll write e plus h. E plus h. So instead of x, I wrote this minus e into 3 power minus 3 power 1 divided by e minus of e plus h. Okay now, limit h approaches 0. So this is this minus f of e is 0. F of e is 0 whole divided by h. Again plus c minus c gets cancelled. Plus h and into h and divided by h will get cancelled. Here if you substitute h as 0, what do we get? First of all, limit h approaches 0. It is 3 power minus 3 power. Here you will get 1 divided by minus h. Correct or not? 1 divided by minus h. Plus c and minus c will get cancelled. Minus h will come. Right? So, and can you pause the video and try to find this value? Anyhow, I am going to explain here. when h is approaching 0, minus 1 by h is approaching minus infinity, and dear students, 3 power minus infinity is 0. This time we got 3 power minus 0, that means 3 power 0 only, which is equal to 1. Dear students, RHD is equal to 1, but LHD is equal to 0. So LHD is not equal to RHD, and then what is the conclusion? We can say that the function is not differentiable at x is equal to e. That is the conclusion. The function is not differentiable at x is equal to e. See, observe, it is continuous at x is equal to e, but not differentiable at x is equal to e. They can frame the questions. How they will frame means in option 1, they will say it is continuous at x is equal to e, but not differentiable. In option 2, they will say it is continuous and also differentiable. In option 3, it is neither continuous nor differentiable. In option 4, they will say cannot be determined. This kind of options will be given, and you can easily choose the correct option. It is continuous at x is equal to e, but not differentiable at x is equal to e. This function is not differentiable. Where at x is equal to e. Okay, now so at remaining points it might be differentiable. We'll discuss it later. Okay, now let us go for the next question. Okay, here is our next question. Discuss the differentiability of f of x is equal to root over 1 minus root of 1 minus x square at x is equal to 0. Obviously, if you check continuity first, let us check continuity. At x is equal to 0. In this case, there is no need of finding LHL or RHL. Okay, now so directly we can find the limiting value of the function. Limit x approaches 0 f of x. See, x is only approaching 0 and it is not equal to 0. Okay, now wait a second. Find limit x approaches 0 f of x. Limit x approaches 0. F of x is always equal to this function. At x is equal to 0 or not at x is equal to 0, it doesn't matter. F of x is always this particular function, so I'll take this. See, I can easily, first we'll go with the direct substitution, correct or not? When I directly substitute x is equal to 0, I'm getting a finite value. So root over 1 minus root of 1 minus 0 square. So what I'm getting is root over 1 minus root 1 is 1, I'm getting 0. So using direct substitution itself, we have found the value of the limit, which is 0. Limiting value of the function is 0, and what is value of the function? Value of the function is also obviously the same thing. Root over 1 minus 0 square, which is equal to 0. So the limiting value of the function is equal to value of the function. The limiting value of the function is equal to value of the function. For this reason, we can say that f of x is continuous at x is equal to 0. Since function is continuous at x is equal to 0, let us check whether it is differentiable or not at x is equal to 0. Okay, let us check differentiability at x is equal to 0 using LHD and RHD. Okay, now I'll do LHD. I think obviously you can do RHD. Okay, observe how we can find left hand differentiability. LHD is equal to limit h approaches 0 at input x is equal to 0, right? F of 0 minus h minus f of 0 whole divided by minus h. Okay, now it is not plus h, remember. So f of minus h, dear students, f of minus h is root over 1 minus root over 1 minus. Instead of x, if I substitute minus h whole square is h square minus f of 0. Already we have found f of 0. You can also find here again. F of 0 is root over 1 minus root of 1 minus 0 square. If you simplify, you will get 0. Okay, now you can find it yourself, divided by minus h. In limits chapter, we have already learned how to simplify these kind of limits using rationalization method. Because if I directly substitute h as 0, I am getting 0 by 0 form. So let me rationalize the numerator with its rationalizing factor. So what is it? Limit h approaches 0. The numerator is under root 1 minus root over 1 minus h square, and the denominator is minus h. I am rationalizing the numerator by multiplying with its rationalizing factor. What is the rationalizing factor of it? Root over 1 plus root over 1 minus h square. Okay, now Don't take plus here also. Just before the root, if it is minus, then before the root it will be plus. That's it. I multiplied it in the numerator, so I should also multiply in the denominator. Next, if I multiply the two terms in this numerator, I'll get single root of, what is it, limit h approaches 0, under root of a minus b into a plus b is a square minus b square. A square minus b square, and denominator is minus h into under root of 1 plus root of 1 minus. In this term I can substitute h as 0. I can take h as 0 because obviously it is a finite value. So inside this particular root, square root and square will get cancelled. Please observe that minus is for both the terms, and limit h approaches 0. Plus 1 and minus 1 will get cancelled. Minus into minus h square will be plus h square. Wait a second, it is not, it is h square only, but under root. So root over h square divided by minus h into this value is root 2. And dear students, root of minus h square is equal to plus h because h is already positive. Okay, now so this becomes h, and h will get cancelled. I am getting minus 1 by root 2 as value. So LHD value is minus 1 by root 2. Will you find what is RHD? Okay, now you can find what is RHD, and if you find RHD, you will get RHD, right hand differentiability, as plus 1 by root 2. Here itself, RHD means f of 0 plus h minus f of 0 divided by plus h. Same simplification itself. Finally, you will get 1 by root 2. So LHD is minus 1 by root 2 and RHD is plus 1 by root 2. Obviously, LHD is not equal to RHD. So therefore, what is the conclusion, dear students? The function is not differentiable. The function is not differentiable at x is equal to 0, as LHD is not equal to RHD. So I hope all these three model questions which I have explained now is clear for you. Okay. Now let us take a different model question. Obviously, in the next question also we will find LHD or RHD, but please observe how different it is compared to 1, 2 and 3. Okay. Fourth question. Observe fourth question, it's important. First thing is, I would like to recommend you to solve this question before you go through the solution of this. Check whether it is continuous or not, and check whether it is differentiable or not, and then check this solution. Okay, now just pause the video and first try it yourself. Anyhow, I'm explaining it. I'm going to first check continuity. Okay, now let me check continuity at x is equal to 0. In this case, LHL and RHL are not needed. Directly I can find the limiting value of the function. So limit x approaches 0, f of x is what? So limit x approaches 0, f of x is, because x is only approaching 0, x is not equal to 0. F of x is x into sine of log x square base e. First thing is, let me see what happens if I directly substitute x as 0. I'll get 0 into sine of, please observe one thing, dear students. X is not exactly 0. X is only approaching 0 now. It is 0 point something. This is 0 point something whole square is 0 point something. And log of 0 point something is approaching minus infinity. Log of 0 point something is approaching minus infinity. And sine of minus infinity is not minus infinity. Sine of minus infinity is some finite value between minus 1 and plus 1. But don't think it is a fixed finite value. I am not saying that the answer is exactly this value. No, it is a finite value which oscillates, whose value oscillates between minus 1 and plus 1. Whose value oscillates. It is not a fixed finite value. Its value keeps oscillating as input is approaching minus infinity. Its value oscillates rapidly between minus 1 and plus 1. It is not fixed. Okay, now, but it doesn't matter. Some finite value between minus 1 and plus 1, when multiplied with 0, the answer is 0. Some finite value between minus 1 and plus 1. Let it oscillate rapidly, but it is a finite value after all. When multiplied with 0, the answer is 0. The limiting value of the function is 0. And what about the value of the function? F of 0, that is also 0. So dear students, the limiting value of the function is equal to value of the function, and because of this reason the function is continuous at x is equal to 0. So the function is continuous at x is equal to 0. Since it is continuous, now let me check whether it is differentiable or not at x is equal to 0. So let me check the differentiability at x is equal to 0. First I will go with RHL, or you can also RHD. You can also try with LHD. Let me see what happens with right hand differentiability. F dash of 0 plus. So which is limit h approaches 0, f of 0 plus h minus f of 0 whole divided by h, because it is RHD na. So dear students, what is f of h? What is f of h? H is not 0, so I can use this function. Limit h approaches 0, f of h is, instead of x we are taking h into sine of log h square base e minus, what is f of 0? When input is 0, the output is also 0. So f of 0 is 0 whole divided by h. In this case, after plus h and minus h gets cancelled, we are getting sine of log of h square. Dear students, sine of h is only approaching 0 na, that means 0 point something. Then h square is also 0 point something. And log of 0 point something is approaching minus infinity. And sine of minus infinity is a finite value between -1 and +1, but it is not a fixed finite value. It rapidly oscillates between -1 and +1. It is not a fixed finite value. The value of sine of minus infinity rapidly oscillates between -1 and +1 in such a way that we will not be able to find what is that finite value. For that reason, we say that RHD is not defined. Since RHD is not defined in this case, what is the conclusion? Since RHD is not defined, the function is not differentiable at x is equal to 0. Just like that, even LHD also will be not defined, but it doesn't matter. Only one person is enough. Can you check LHD and can you check what answer will come? Even LHD also will be same answer. Okay, now I have done RHD, right? You can try with LHD. Okay, since the right hand differentiability is not defined, the function is not differentiable at x is equal to 0. That is the conclusion. It is continuous but not differentiable. But for what reason? This is the reason. Okay, now fine. Let us go for next question. I hope this model is useful for you. You have understood this. It is obviously different from the first 3 models, right? So 4 questions are completed till now, and I think your confidence level on this particular concept is better now after solving these 4 questions. Do practice. Don't forget that. Let me go for next question. Here is our next question, which is a different model question, which also contains step functions. Please observe. F of x is equal to step of 2x into sine of 3 pi into x. Then they told us to prove that the right hand differentiability at n. Okay, na? So f dash of n plus is equal to 6n pi into minus 1 power n. And what is n here? N is a positive integer, and this is the greatest integer function. Okay, na? So they told us to prove that this is equal to this. So obviously it is enough to find f dash of n plus. No need to check for continuity, no need to check LHD. Directly RHD is enough, right? So let me solve the problem and let me directly find right hand differentiability at x is equal to n. So RHD, what is it? F dash of n plus is equal to limit h approaches 0, f of n plus h minus f of n whole divided by h. So it is equal to, what is f of n plus h, dear students? So instead of x, let me substitute n plus h. So step of 2 times n plus h into sine 3 pi into, instead of x, I will write n plus h minus, what is f of n? F of n is step of 2n into sine 3 pi n, where n is a positive integer, whole divided by h. And don't forget to write limit h approaches 0. Now you should have the basic idea about step functions. What are their properties? All these are very important. 2 times n plus h is 2n plus 2h. And dear students, if 2n is an integer, it does not need the step function. So step is enough only for 2h. That is a property of step functions. What is the property of step functions? Step of x plus n is equal to step x plus n, and step is not needed for n if n is an integer. Okay, now step is enough only for x. That property I am using here. 2n is an integer, it does not need the step. So 2n plus step of 2h. Okay, now so into, take 3 pi n, 3 pi inside, sine of 3 pi n plus 3 pi h, and then dear students, sine of 3 pi into n is a integer only na. Sine of any multiple of pi, any integral multiple of pi is 0, and at the same time step of 2n is integer, so step of 2n is 2n only. 2n into 0 will be 0 whole divided by h. Okay, now so two more steps we will get our answer. So what is it? Let us see. So once again, step of 2h is 2h. Wait a second. 2h is what? 0 point something, because h is approaching 0. H is 0 point something. 2 into h is also 0 point something, and step of 0 point h something is 0. So we will get only 2n here. 2n, 1 second. Limit h approaches 0. Limit h approaches 0. This is 2n into, now it's time to understand this. N is an integer. This is h and this is n. N is an integer. Dear students, what if n is 1? We will get sine of 3 pi plus. 3 pi plus means where, in which quadrant we are landing. So this is pi, this is 2 pi, and again this is 3 pi. 3 pi plus means we are in third quadrant. Then sign will be negative. If n is 1, I am getting minus sign. And what if n is 2? 3 pi into 2 is 6 pi. And where is 6 pi? 3 pi, this is 4 pi, this is 5 pi, and again this is 6 pi. So if n is 2, I will get what? 6 pi plus. This is 6 pi. 6 pi plus means we are in first quadrant. And in first quadrant, sign is positive. So dear students, so from this we can say that if n is a odd number, I will get minus sign, and if n is a even number, I will get plus sign. For this reason, what I am going to do is, we can write this as minus 1 power n into sine of 3 pi h. See here, if n is odd number, I will get minus 1. And if n is even number, I will get plus 1. Correct or not? If n is odd number, we are landing into third quadrant and we will get minus sign. And if n is even number, we are landing into first quadrant and I am getting plus sign. For that reason, I am writing minus 1 power n. If n is odd number, I will get minus sign here. And if n is even number, I will get plus sign here. So this can be ignored and sign of 3 pi h will come there. Because if n is odd number, I will get minus sign 3 pi h. If n is even number, I will get plus sign 3 pi h. So I have written this. I hope you will understand this. Whole divided by h. And what is this, dear students? From limits, trigonometric limits, we have learned that when h is approaching 0, sine of kh by h is taking what value? K. Correct or not? Sine of k into h divided by h is taking the value k. So the value of this is going to be 3 pi. So what is the answer? 3 pi into 2n will be 6 pi n into minus 1 power n. So did I get the same answer? Is it what they are asking us to prove? 6 pi n into 6n pi into minus 1 power n. So we have proved that RHD is equal to 6 pi n into minus 1 power n. For a practice of these kind of models, why can't you find what is LHD? You can try to find what is LHD and you can let me know what is the answer in comment sections. Is it clear? So dear students, I hope the 5 models which I have used here is very useful for you and it has given you a very good clarity on the problems on differentiability. Let me explain one more model and then I'll wind up the video. Here is our next question. So it is given that f is an even function such that this particular value is equal to k. What is it? Limit h approaches 0, f of h minus f of 0 by h is k, where k is any real number but not 0. K is any real number but not 0. Okay, now they told us to check the differentiability of f of x at x is equal to 0. Dear students, let me check the differentiability directly instead of using continuity. Because they are talking about, what is it? They have given this particular value, limit h approaches 0, f of h minus f of 0 by h is k. I'm supposed to use this. Where will I use this particular formula? In differentiability only. So for that reason, let me directly go for differentiability. First, let me find what is LHD. Okay. So LHD is equal to f dash of 0 minus, because you are checking differentiability at x is equal to 0. This is limit h approaches 0, f of 0 minus h minus f of 0 divided by minus h. Don't forget minus h in the denominator. And since f is an even function, dear students, f of minus h is same as f of h. Because f is an even function, f of minus h is same as f of h. And let me take this minus outside. So minus limit h approaches 0, f of minus h is same as f of h minus f of 0 divided by h. So minus, according to question, this is given as k. So what is the answer? LHD. I got LHD as minus k, where k is not 0. Okay, now if you try to find RHD, can you pause the video and can you try once and can you check what is RHD? Obviously, RHD is equal to f dash of 0 plus. And what is RHD? f of 0 plus h minus f of 0 divided by plus h. So you will get this. And this is nothing but plus k. Dear students, I got left hand differentiability as minus k and right hand differentiability as plus k. Obviously, LHD is not equal to RHD. So what is the conclusion? What can you say about differentiability of f of x at x is equal to 0? We say that f of x is not differentiable at x is equal to 0. That is the conclusion. I hope the problem is very simple and I hope you have understood this. So dear students, these are different models on LHD and RHD. In the upcoming videos, we will see how to find the differentiability using other ways. See, in these problems, we have checked the differentiability using what? LHD and RHD. In upcoming questions, we will check whether a function is differentiable or not using differentiation. We will check whether a function is differentiable or not using graphs. All these models will be seen in the upcoming videos. So hope you will check the remaining videos also. In case if you have understood these problems and the concepts of differentiability, don't forget to like the video and do not forget to share it to your friends. This is very important. Let the channel grow. So thank you, dear students, and if there is any feedback, let me know in the comment sections. Don't forget to give a proper feedback on this video. If there is something more that you want to know from these concepts, obviously I'll upload those videos. Don't forget this. We'll see you all in the next video. This is Sandeep Kumar. See you all. Take care.